Okay, this is 2.3 and 2.4, polynomial and rational functions. Use long division to divide polynomials by other polynomials. Use synthetic division to divide polynomials by binomials. Notice it only works for binomials of degree 1. Use the remainder theorem and the factor theorem. Use the imaginary unit I to write complex numbers. Okay, that part is section 2.4. So 2.3 is above, 2.4 is below the line. I apologize for that popping up. I hit it accidentally. All right, long division. Use long division to divide polynomials by other polynomials. I have x minus 1 quantity squared. I'm going to multiply that out. So I'm going to FOIL. That becomes x squared minus 2x plus 1. So that's what I'm going to factor squared plus 1. I have 2x cubed minus squared. So I have to ask myself, what do I multiply x squared by? What do I multiply x squared by? I get 2x. The answer is going to be 2x. Anyway, long x. All right, 2x. Over 2x times 2x times negative 2x, I get negative 4x. All right. 2x times 1 gives me plus 2. All right, notice this falls away and that falls away, so I'm not going to have to have it. Okay, so now we have 2x plus 8. That does not fit, right? I can't multiply x squared by anything to get 2x. That doesn't make sense. So what I have then, my answer is 2x plus 2x plus 8, because this becomes my remainder, divided by x squared minus 2x plus 1. Okay, now, the thing I want you to remember, this can also, there's another thing that WebAssign does. If we say this is f of x, what we're now saying is that f of x is equal to my divisor, okay, times another function plus the remainder. Okay, so what this would be in this case is x minus 1 squared. My p of x in this case is just the 2x. Plus my remainder is 2x plus 8 over the divisor. So it could be written in this manner, and WebAssign will have you do that. Synthetic division. This was the fun one. All right, so I'm dividing it by x minus 6. So I flip it. I get an x equals 6 as a factor, so I'm going to divide it by 6. So I write my 6, and then I write all my coefficients. I have 10 on the 4, negative 50 on the 3. I have no x squared, no x, and negative 936 on my, as my final constant. So I have 6 times, no, sorry, I just bring this first number straight down is 10. 6 times 10 is 60. Now I add them. Actually, you know what? I'm going to do that part in a different color so it becomes more obvious. I know some of you will be quite rusty on how you do synthetic division. Okay, so we're going to change to green. We bring the 10 straight down. We take this 6 times the 10, and that's going to give me 60. I add the 2. Actually, I think I'll turn that to red. I add the 2, and that's going to give me 10. Okay, now I take the 6 times the 10, and I get 60 again. Whoops, should be in green. We're going to be consistent here. Nope, that gave us 60. And then we're going to add those, which is 60 plus 0 is 60. 6 times 60 is 30 times 60. So 6 times 60. All right. We add them. We have 360. Now I have 6 times 360. 3 times, sorry, 6 times 360. I'm going to 3 times 360 gives me, oh, not 360 cubed, goodness, 3 times 360 to say. That's a lot much. 1080. 6 times 360. 2160. All right, so that was 6 times 360. Now we add those. And we get 1224. All right. Synthetic division. We can say that this is now 10x cubed plus 10x squared plus 60x plus 360 plus 1224 over 6. No, it's over the x minus 6, sorry. Maybe there's something else to it. X minus 6. Okay. Remainder theorem and the factor theorem writes a function in the form of, see, this is what I was talking about, that x minus k pq plus r for the given value of k. So what we'll do is k is 1/5, so we have x minus 1/5. And we're going to do the math, and that comes from here with the remainder. Okay, so this is 1/5. We can do it with long division, or we can do it with synthetic. So I personally like synthetic. So I have 10 minus 17 minus 3 and 3. 10 comes down. Multiply, I get 2. Negative 15. Multiply, I get negative 3. I'm adding, so I have negative 6. Negative, and this gives me negative 6 over 5. So that 3 is 15 over 5. 15 minus 6 is 9. So this becomes 9 over 5. All right. So x minus 1/5 Q of k x is 10x squared, okay, minus 15x minus 6 plus my R. My R was 9/5. Demonstrate this is true. You remember, by plugging in the 150, you can use it. You can also just here. That becomes 9/5. That's R. All right. Use the remainder theorem and the factor theorem. Use synthetic division to show that x is a solution of the third degree polynomial. Use the results to factor the polynomial completely and list all real solutions. So what we have is 2, 1 for the x cubed, 0 for the x squared, minus 7 for the x, and a 6. So I bring this straight down. I have a 1, 2, 2. 2 is 4, negative 3, negative 6, 0. This tells me no remainder. This now becomes x squared plus 2x minus 3. All right, so we have this, now we can factor. Factors of 3 that subtract to 2, 3 and 1. Oops, the larger is plus, so that's the 3. All right, bring that up. Now, so that's one of our things. Now remember, we already took a factor out of x minus 2, which was the positive 2 I divided out. Enter your answer. Okay, list all real solutions. So I'm going to include the one they gave me. So all real solutions are 2, negative 3, and positive 1. There we go. Those are all my real solutions. All right, go do your in-class practice 1 through 4. And then there'll be another video.